Yo, this is Nomifactory hard mode. Um, Different kind of video today. It's basically an announcement video. We will not continue the series here. I will start a fresh one because I recognize that we are basically kind of in a hole. Um, the problem is a little bit. Whoops, I was in another world recently. Um, the setup here, what we're doing, it's not, in my opinion, future proof. Um, we have a lot of stuff that is not working and that I'm not satisfied with. And I have developed some solutions for that. One of the first things is the energy system that we have or that I used. Um, there is a better way on how to like currently what we have to do basically is we have to say, okay, we have here our ZPM uh, substation dynamo and the energy hatch, right? The energy hatch is just from these guys here. Um, but the problem is the dynamo hatch. We basically limit ourselves to specific like a, to a specific voltage tier. Um, that is. It's kind of intended, I reckon, from the developers, but there is a workaround. I will show you all of the workarounds in next time or in, in a short while. This is just one of the problems that I wanted to point out. The second one is kind of like this here is all fine in my opinion. Um, you could kind of separate this a little bit. That think that the output of these guys, if you don't, yeah, maybe that you kind of have a second quad EBF or something like this. But the biggest issue that I'm having is with the micro miners. Um, and I have developed a solution for that. That's actually crazy. So the problem is, if let's say kind of the next step here would be to craft another HPCA, right? So I just want to show you guys what is going on behind the cameras. So let's say we want to craft another HPCA, right? So we can do that, right? No, we can't. Because for whatever reason, we're missing one SMD capacitor. And we need to craft 2860. Same thing is with here. We need 25 million chlorine. So what is going on? Basically, or also we need like 16 tungsten dust. I need to craft 258, which, by the way, with 1058 shelit dust. So what is going on? What I encoded here is what I think still is a good thing. Let's look at the recipe, right? So if we put in here a steel to plate microminer tier 1, some rocket fuel, one quantum flux in a chest, we get out 128 nickel, 128 uraninite, 256 purified galena, and I think this is molybdenum. Whatever, it's not that important. But the point is, basically, you say we put this in here. Like you craft the microminer and the other stuff, you put it in here. Then all of the ores are getting pulled into here, right? Into the steel crate. Go through the ore processing, and then you get something out. The problem, what it cannot handle, is this dependency. What I mean by that is, for example, it's I think with the tier 5 microminer, it's the most apparent. Like here, you need iridium, and these guys don't know how to get iridium, right? So that's just the problem. So these self dependency loops, the ME system cannot handle. And one of the rules, quote unquote rules, in this playthrough was to kind of use only things or only stuff that we wanted to craft, like a passive only stuff that really needs to be passive. For example, the energy was one of the things that I wanted to passive. Also, second thing is here, this guy. There's a better solution for this. Like, you need to, I think, have at least or at most 2 of these. Also, I have to kind of confess, most of these were cheated. Like, I can cheat here. Like, I enabled this because it took 50 hours, like, to even craft like one, because we only had like one fusion reactor, and this wasn't. I know now it's not enough, but yeah, next time we will get to all of the changes that I want to do in the next season. Um, so also one of the things that I only noticed or quite recently is this stuff here, right? This is UHV. How can this be UHV? You just have to have these 16 amp, 16 amp energy hatches. You should use them on multi-blocks wherever you can, because then you can fully parallelize the stuff. What I thought how it works which would have made sense to assume that is, let's say we have like 16 cables, right? Or we want to do like copper cables. Um, so what do we need for that? We need let's do this one here. So 36 styrene butadiene rubber and 1 copper wire, right? What the problem is, or what I thought is, um, that you can just paralyze this. Like, you need still only 700 EU, or like use like 7 EU per tick. It takes 5 seconds, but you can craft 4 of them at the same time, which is not the case. What is the case is that you need 4 copper wire, or 4 times 36 styrene butadiene, but also 4 times the energy, because every paralyzed craft, like the 4 times, needs the same energy. Like, they don't share the energy, but they kind of use their own energy, and therefore they need to paralyze this. Um, Also, one minor thing, what I want to change here is this one. Oh, this is way too much and way too non-paralyzed. I want to basically find out what is the smallest kind of reactor that you can build, so that we can then paralyze it as well. This one here is all fine in my opinion. I really like this. Up until here, yeah, there's a lot of free space there, but yeah. Second thing, or next thing, is we also need to overclock basically these guys here. As you can see, we are here at UEV. Max recipe tier is UV, but this doesn't really matter. Here, these ME input buses, they are great, by the way. So use them. So for example, this one here with depleted fuel, this was a problem. But what I wanted to get at is whatever is in there. This is Bonit and so on. Yeah. Okay. One big thing, flatline. We take quite a lot of time to produce 1 iridium and so on. And this is why in the next season, I want to actually passive that. And I'm basically mapped out all of the steps of the flatline, and we can actually, or you can build it, but we want to have then 1 dedicated machine for each of the processing steps. Same thing, by the way, goes for Shellito. I also had a lot of trouble with this recipe here, because the ME system cannot, for the love of God, cannot recognize that you can do both. Like, you get 28 tungstic acid from tungstate and also Chili. It cannot recognize it. So this is why we want to do, or this is why we want to have kind of a dedicated line, quote unquote, where we actually produce tungsten ingots. So yeah, but I will show you this. Next thing, this thing here. I cannot tell you guys how many times I had to I had to basically farm out rock salt. Like the most farmed item I think in this playthrough is rock salt, or in this current world is rock salt, because we need the chlorine. But again, there's a better way. Um, it's salt water. The good thing is salt water, it doesn't deplete. So depletion chance 0. What you do is you do two things. One of the things is you do for sodium hydroxide. This is what you want to do. Like you centrifuge, you electrolyze it. The second thing is um, you want to centrifuge it and also then electrolyze the salt. These are kind of the things that we want to do. This is how we get chlorine en masse, and we always kind of um, want to have the biggest tank available that we can use. Next thing, hydrogen. How do you get hydrogen? We also will set up a dedicated line, and that is the hydrogen line. What you do is, because for example, you needed so much for iridium and the platline and what's or not. Where is it actually? I want to find it, please. Ah, yeah. So with 1 carbon and 4,000 hydrogen, you get 1,000 methane. With 1,000 methane, you get, or you can do, and 2,000 water, you get 8,000 hydrogen and 1,000 carbon dioxide. So the loop is basically have some hydrogen and 1 carbon, produce methane, put that into in a chemical reactor, produce methane. The methane then goes with water into a chemical reactor to get hydrogen. 4,000 of the hydrogen goes back into the original chemical reactor, and the carbon dioxide you need to electrolyze to get the oxygen and to get the carbon back, and the carbon you also then feed back into this one. Why do we want to do that? Yeah. So these are the main issues that I had with this playthrough. And this is what we actually want to fix in the next attempt, in the next session. The next session, because this year is a server, by the way. So I also had some times where I had to restart my AME system because the power was running out. We don't have enough oil and so on. Also, something very important is raw oil. In the void, you have infinite, basically. And of course, yeah, you get only 10 liters of sulfuric acid and so on. You could, quote unquote, do that. But yeah. So, what kind of improvements do I have? This is where I need to switch world real quick. I have here the test world, where I also want to, yeah, show some stuff. So, the first thing, or one of the biggest things, is so by the way, this is the whole platline mapped here out. So the crates are the orange crates, the bronze crates. They are also always the input. For example, here you put in chalcopyrite, chalcocite, bornite, and so on. With nitric acid, the value is not correct because you only need like 100. But it's kind of a passive thing that we also want to do. Nitric acid, when we have hydrogen and nitrogen and oxygen, we want to do that. And then you get platinum group sludge, or 2 or 4 out. And yeah, then for example, with 1 platinum group sludge and 2 aquaregia in a chemical bath, you then get here platinum group residue, platinum sludge residue. I didn't do the platinum palladium legitate. I need to know what we need to do for that. So this is not finished apparently. But yeah, we will. I think we will do that at some point. Or I will just add that. That's not a problem. But we have some major improvements. Also, quick note here. Um, this is here the yeah, tungsten line. So you put in tungstate and chelate and some hydrochloric acid, and you get then out this tungstic acid and the stuff that you need to then yeah, electrolyze back. But yeah, then you need an extractor into EBF with carbon, and then you get like two hot tungsten out and then into a vacuum freezer, and then you get tungsten ingots. The good thing is then you can recycle them, quote unquote, into tungsten dust. I didn't want to add that here because sometimes you need tungsten ingots. So let's get here to our um, main improvements, in my opinion, that we have. The first thing is we need to craft more energy converters, and we want to rely on energy converters. So what the problem was, if you have an LUV energy converter or LUV storage, for example, you can in theory only use LUV or higher voltage tiers, right? With this setup, you can't. You have some losses in there, quite admittedly, but and I also need to see how to add or kind of use central storage for that. I don't know. Maybe I want to slash need it. But what we basically do is we have some input. This can be any kind of voltage tier. Usually you want to match those. So this usually matches. So the like it's either lower or the same. Like here we have HV combustion generators. They feed into a battery, and now comes quote unquote the magic. We convert that to RF, and then we have basically one distribution system or basically one frequency for peer-to-peer that we need to use, and then we can use this one, and then we can energy convert this into the energy that we need or the tier that we need at the point. So this, for example, here is only an HV hammer, so we're basically skipping EV here, but we can use an EV thing here. So second thing is the following. Let's do the stuff first so that I can explain the microversim stuff here. If we use a storage bus and an interface with a crafting card, we can order things. Let's say we have now 64 here. If I take that out, you will see here we craft that. Obviously, for gravel, that's kind of a little bit stupid or a little bit unnecessary, but we can do it, for example, for a tier 5 microminer or a microminer in general. Because then comes now the magic. The problem of controlling a multi-block with multiple outputs, and you need some of the outputs. So here, for example, we have liquid air, right? We are doing liquid air distillation. And we want to control now. We want to control now all of the outputs. So we need not only nitrogen, but also hydrogen and maybe helium and so on. What we can do here is we can have. I can show you this real quick. This is basically the same setup, and we will use it on the microminers. By the way, and we basically have. Let's show this real quick. So we have here a machine controller that is inverted. So it's only it will require a signal to run, and then oops. Output, and this can be then also output. Yeah, this needs to be done like this. So this needs to basically be the same quote unquote frequency or color. And then we kind of put this into emit when levels are below. So what happens is And I can show you this here. Oh, let's quickly get an interface. Or let's do it like this. I have now, like all of them are here on 1,000 buckets, right? So we activate when we have 1,000 buckets. Now we have like 20,000. So let's get a drum here real quick. And let's see if this activates. And it does. Same thing, by the way, for nitrogen. So every distillation we can now use in that way. So for example, if we have only raw oil, but we need, for example, not only heavy fuel, but also light fuel and naphtha, we can just put 3 of these guys in there and yeah, activate them like this. So we only have like one machine. And the cool thing is we can, if we want, we can multi-process that. So let's say on this side here is another distillation tower. We can kind of put the same logic to the other side so that we have a higher regeneration time or recuperation time. So basically, we get the outputs faster, right? Instead of overclocking, we just get the output faster. Why is this important for the microverses? Because now we can, um, sorry, micro miner. Because now we can control this one. We can say, like we put in passively here, we put in a tier 1 micro miner. We let also the rocket fuel craft and also we let also the rocket fuel craft and also the chest and the quantum flux. And then we say, okay, if we need then 64 dilithium, then only activate like the only activate when we are below that number. And for example, for diamonds is then, because this was also a big problem, diamonds, you need a shit ton of diamonds later on, but we will also come to that, how to get a lot of diamonds or a lot of ore in general at IV. Um, but yeah, this is how we can control then here every single one of them. Like if we need ilmenite, if we need uraninite, I think also ilmenite, we want to then passive, or maybe even the rutile thing, because usually I think rutile, right, we don't need it for anything. Yeah, you can get titanium chloride, but dude, no. Also, this one here doesn't really make sense in my opinion. But yeah, so the only real issue is we need then this loop here. Yeah, for titanium. So we passive then titanium. This is also something which is kind of easy. You just have some carbon, rutile, and some chlorine. You get the carbon monoxide that you then electrolyze into carbon and oxygen. The oxygen you can throw away, basically, or kind of put into the mainnet again. Yeah, subnets is also something that we want to use extensively. Then the titanium chloride with some magnesium, you put that in, right? You get one hot titanium out. This goes into a vacuum freezer. This one here you need to electrolyze again into then magnesium and chlorine, and you feed that magnesium and chlorine back into the electrical chemical reactor. That's it. Oops. So now let's actually get to the biggest thing that I didn't do, and I don't know why, but for some reason you need to do it. I don't know why the game is like this, but hey. So, what is the problem? This one. How to get trinium. Trinium is something you need a shit ton later on in the game. And this is also one of the big struggles that I'm having, especially for titanium blocks or superconducting blocks, or yeah. Then here, these guys here, europium is a second one, by the way. Just that you know that. But how to get trinium? There's only basically one way to get it, and that is electrolyzing chiamantite. How do you get chiamantite? You could do this one here, which is kind of not the intended way, because you need a lot of passive stuff and so on. You get some snow chestite and so on. And pitch blende, borax, raw earth, snow chestite, diamond, and so on. Red and yeah, so distilled water. Like, you can set this up if you want to. You get a lot of stuff out that you really don't need in the late game. But yeah, there is, I think, this guy here, which gives you 24 chiamantite. So, how do you get? You get 48 divided by 6. So you get 8 trinium. You need thousands. What is the solution? The solution is over here. You can abuse them. And this is basically the setup how to abuse them. So you have here 2 things, and basically, yeah, I'll explain it. So here we have our formation planes. With that, we can, if we drop something into the ME system or into the subnet, we can place them. Just a quick reminder that this works. So we can drop in here some ores. They get kind of they get placed, and then it's kind of important. These annihilation planes, they can only kind of mine cobblestone. So basically, the idea is we place them. The miner mines it, and then we kind of mine the cobblestone into here. Why is this important? Because now you get 4 times the amount. And I mean, for any ore that you want, you can get 4 times the amount. For example, if you need diamond, right? Even with this dense diamond, you get like 16. So instead of 2, you get an 8. Right? Just to prove that. You get 8. Same thing with osmiridium, for example. Osmiridium, right? Where do we get it? You get like 6, which is not what I wanted. It's then the reader's mind, right? That has 2. Yeah. So for example, here 24. It's not 48, but it's then 48 times 4. So 48 times 4. So 192. And then if you go through the chain, right? You divide that by 5, so you have 38 times 4, 152 iridium, or 38, or 38 osmium. So basically, Flatline is then useless. Also, for example, Laurite. You would get then, like, yeah. Also here, this one, right? So one of the problems is kind of the sifting recipes that you need to sift stuff. But this can be automated. So basically, the idea is, if we want to have, for example, chiamantite, We do that here. Let's say 1,000 or 1,024. Um, the tier 5 microminer gets crafted. Um, the tier 5 microminer gets crafted. It gets then put in here. Also the other stuff, right? So what is it? Yeah, stabilized uranium and quantum flux and so on, or stabilized plutonium. It does that, and then the ores, all of the ores get dumped in here. The output goes into our ore processing facility, and from there it's basically game on. And then afterwards, you don't need a macerator anymore. Like you don't need this initial macerator anymore, which is kind of, in my opinion, great. So what I mean with initial macerator, it's this macerator here. As you can see, I cannot fly again. This macerator, you don't need it anymore. So you just have like one point, and we crush them. The crushing is done by the ordering plant. We get then into here the storage buses, and then yeah, it's basically then goes through this one, and this one, and then also the electrolyzer. And then here, a lot of the stuff then here is also kind of just for processing. So, for example, this one, these guys here, they do pyrochlor and tantalite. We need that. This one here is working on hydrofluoric acid. This is also something that we need. So fluorine processing is something that I want to do, but fluorine plus processing is also pretty easy. Because yeah, yeah, I think you only really get it from, yeah, you can get it from lepidolite, but what you need mostly from is biotite. And biotite, what you can do is just to show you this. If we have the advanced if we have the processing arrays, we can just put in here. We can put in here a rock breaker, and it doesn't need any of the. And we have like 4 million obsidian now. You don't need any of the stuff, and you can do this with every rock breaker, by the way. So all of the rock breaker stuff. Cobblestone, come on. But andesite, for example, could be interesting for andesite dust, where you get some salpeter out. And asbestos gives you hydrogen, magnesium, and silicon and oxygen. So this could be interesting. Granite is for thorium, maybe interesting. But yeah, you get it for silicon dioxide. So this is just silicon and oxygen, but also some red rock dust, calcite, and flint. So if you need calcite, do it. Diorite, diorite dust is mirabilite and clay dust. Clay dust is mostly sodium, so aluminium, lithium, silicon, and sodium and water. Mirabilite is then also water, some sulfur and sodium, so this is not so good. But yeah, you can also do it for obsidian, for example. Obsidian, if you do obsidian dust and electrolyze it, you get magnesium, iron, silicon, oxygen. So, kind of interesting. Marble, I really don't know. Marble dust. Concrete, okay. Yeah, magnesium and calcite. Okay, this is kind of interesting for calcite. But yeah, basalt is then here interesting for calcite, olivine, and flint, but also not that. But yeah, red granite you get for uranium 238. You could do that. Red granite is then just aluminium, oxygen, and potassium feldspar. But yeah, this is great for uranium. And black granite, of course, is for thorium and black granite. Black granite, you get biotite. So it's basically 22 times 5. So 110 for 2000 fluorine and one potassium. But yeah, this would be then kind of the point. But yeah, this is how you can do rock breakers. But yeah, this is kind of the ideal setup that I want to do. Also for the clean room, we will build that. I think a lot higher slash maybe passive some stuff. Also, this one here is way too cramped. As you can see now, the reconstruction chamber is different, and I want to basically have that out in the open. So yeah, but yeah, this is for the update video. I think we have most of it. Yeah, for example, what you also could do is snow. The problem is a little bit if you do Naquata processing, right? Um, if you do Naquata processing, right, you need to kind of have some Naquata, or you need to hold some Naquata. So you with fluoroantimonic acid, you get here the stuff. I don't know if I want to do that, but yeah. But yeah, this is it for this update video. So yeah, there are some rules that I want to kind of incorporate and also expand a little bit how to do Nomifactory, because this one here was again this is one of the big culprits. Here you see one of them. I usually don't use enough energy or don't produce enough energy to have that. Usually I'm then content with, okay, if this can run overnight on a server, you just say, okay, just queue a big task and then you just wait, right? But this is not what I want. Basically what I want is to kind of have everything ready at the point. But yeah, don't get me wrong, like this playthrough here, we're pretty close to finishing. What we need to, or the remaining things that we need to do is we need uh just to craft one tier 9, so this guy, one tier 10, so this would require then a lot of stuff, so this is why we need the chaotic stuff. One additional HPCA, and then you just need to craft some mode of omnium, and then some omnium ingots, and then you could, I guess, get this infinity catalyst. Or do we need that? For what do we need it? This one, no. For this one, yeah. Okay, so we need like, this is 1836 of these guys. And yeah, then so maybe more. So 36 plus what is it? Yeah, 2, so 38. But yeah, the chaos shards, for example, are the big problem. But yeah, this is how we would then, like, if we, for example, want to have a micro miner, let's say the micro miner tier 1, we build then one dedicated micro miner or microverse projector. That's it. And then you can get from this recipe all of this one in a passive way. Same thing then with this one. For example, you also need a lot of perfect diamonds. I don't know if this one is better, but yeah. But for example, passiving these gemstones and so on, this would be then you would then craft them up. But yeah. All right, then I think I will upload the remaining episodes, maybe release them and then get this episode out here, or this update video out here. But yeah, I hope in season 2 we will be better in terms of scalability and yeah, how to do Nomifactory. But yeah, see you guys. Bye bye.